So to prepare you for the next lesson, we're going to need to talk about how to construct our unit circle. Now, compared to other classes, I'm not going to have you memorize a unit circle. Rather, I'm going to require you guys to build your unit circle from scratch. So, how do you build a unit circle? First, we got to talk about what the unit circle actually is. All the unit circle is unit circle. Well, the root word is unit, and that means one. So all it is a circle with a radius 1. Now, that radius can be centimeters, feet, we do not know. It's just one unit of whatever we choose. So, and then the next part of our unit circle, we're going to have the x and y axis. X is your horizontal distance, y is your vertical distance. We're going to need to be able to determine the location of points on our unit circle, such as point over here, point over here, point over here. And these are not like 100% up to scaling, but get the idea. We're going to need to be able to calculate all of these locations. We need to find the x value and the y, the ordered pair. Or what your book might say is your actual terminal distance. So to calculate these points, first we need to know common angle measurement for our unit circles. The common ones that we need to figure out are going to be 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120 degrees, 135 degrees, and so forth, etc. All the way to 360. We're going to have to cover all these, parts of the unit circle. So you need to be aware of how to make the conversions already. Everybody should know how to convert these from radians because you might see 90 degrees represented as pi over halves. You might see 30 degrees as pi over 6. You need to know how to make the transition from convert our degrees to radians quickly. So now let's talk about how to actually figure out where the location of these ordered pairs are. How do I figure out the x and the y value of this coordinate right there? Well, in our list, we're going to start off over here at 0 degrees. Okay? This is 0 degrees or 0 radians, and this is the location 0, 0 as an ordered pair. Well, at this location over here, I only have an x value moving to the right 1 because our radius is 1. So this is the location 1, 0. That one's easy. But moving on, the next angle measurement that we have to work with is 30 degrees. So what we're going to be doing for our assignments for tomorrow or anything, we're going to be drawing right triangles with that. So first, you got to draw your radius. We know this has a measurement of 1. Now, how do we draw our right triangles? We are always going to draw a right triangle where our base, the base of the right triangle, is always going to be the horizontal line on the x-axis. So this is the base of your right triangle right there. And in doing so, I have this right triangle right here. Boom. If I were to pull that right triangle out, this is at 30 degrees. Boom, boom. This is what it looks like. And this is 30 degrees. Well, I need to figure out this location. The only way I can figure out that ordered pair is by finding the other sides of my triangle. Now, if you are aware, this is a 30, 60, 90 triangle. So this is automatically 60 degrees. In your 30, 60, 90 degree triangle, it says that, hey, your shortest leg and your hypotenuse is always 2 times your shortest leg. So the shortest leg is over here, so we're going to divide 1 by 2, which is 1/2. And now your longer leg, the one across or opposite of the 60 degree angle, is always going to be square root 3 times your shortest leg. So we have square root 3 over 2. That's just square root 3 times 1/2. So I should show my work. Boom. Now, this represents your x distance your horizontal distance, this will represent your y distance, your vertical distance. So the location over here, we can actually just write this as square root 3 over 2, and this is going to be 1/2. Those are the sides of my triangle. Now, when I write my ordered pair, I went square root 3 over 2 to the right, and I went up by 1/2. So that's my location. That's our first point on our unit circle that we are able to solve out. You need to be able to find your sides of the triangle and then calculate these points respectively. So that's one example. Let's do another one that might not be as obvious. Let's choose an angle measure. Let's see. Oops. Let's do 210. Let's go all the way 210. So I made some unit circles over here. 210 degrees. Now 210 degrees is around somewhere right here. Right? But I don't know how to deal with this because when I do my right triangles, they have to add until 180 degrees. So the first thing you need to do is make sure it's a coterminal angle that's between 0 to 360. Thankfully, this is between 0 to 360. The next thing you need to do is calculate reference angle. Now in your book, we call it reference number for now, and that's just the arc length. It turns out the arc length is the exact same thing as the angle measurement in a unit circle. If the radius is 1 for a circle, they will be the exact same. If the radius is not 1, then your arc length will be different than your angle measurement. But if we have 210 degrees, we need to calculate the reference angle now. So to calculate that, I always need to think about how to draw my right triangle. In our case, we stated that our right triangle, the base is always on the x-axis. So that means this is your base over here for your right triangle. You have to let the bottom part of your right triangle be on the x-axis. If it is not, it is incorrect. Now, draw my right triangle, boom. And the way you can calculate that measurement, well, we see that this horizontal line from here all the way to here is 180 degrees. So if this is 180 degrees, or pi, this is pi, which is equal to 180 degrees, I need to calculate from here. I know this is 210 degrees, so that distance, the way I can calculate it is 210 minus 180 degrees. Now, as a rule of thumb, you are not always subtracting 180 degrees. Sometimes you are doing 180 degrees minus your angle measurement. Sometimes it's reversed. You have to draw your right triangle and see what operation you need to use or what order does the subtraction has to happen. So if I subtract this, I get 30 degrees. That is my reference angle. So that means if I draw my triangle now at 210 degrees, and if you were aware 210 degrees, if you converted that, that would be 7 pi over 6. But if you drew your right triangle, it's shaped like this. Make sure you draw the orientation correctly as well. That is very important. So I know this is 30 degrees over here. That's where my angle measurement is, because remember, our angles, the initial side always starts over here. It goes like this. And then we have 30, 60, 90. This is why we use the 30, 60, 90 degrees, and we have such high importance for them. So on our 30, 60, 90 degrees, the radius is always 1. So put a 1 at the radius. Now with this radius, you can see that if it's 1 over here, we use our 30, 60, 90 property. The same exact property is going to happen. Where this is, what is this? 1/2. So it's just twice the amount. And this is square root 3 over 2. So the location of this guy, now the location of it is a bit different. If I were to draw my values, square root 3 over 2, and this is 1/2. This is located at the ordered pair. Now you have to be careful. I went left square root 3 over 2, and I went down 1/2, which means this is negative square root 3 over 2 and negative 1/2. That is very important. You need to be able to check your signs. And then the last one that I want to do is the last example I'll do here. Let's just do 3 pi over 4. If you convert that to degrees, remember to convert radians to degrees, you're going to multiply that by 180 over pi. If you multiply 180 over pi and you simplify it, you get 135 degrees. And then that's going to be somewhere around here. Right? Now, look at where the x-axis is. That's the base of our triangle, right here. And I'm going to draw a 90-degree angle with that base. The radius is always 1. Now, pull out your triangle. Now, we have to figure out the reference angle. The reference angle is always between 0 through 90 degrees. 0 to 90. This is not 0 to 90 degrees. I know this is 180 degrees right here. So how can I measure this angle measurement, theta? How can I figure out what theta is? Well, to calculate what theta is, well, that's going to be 180 minus our value this time. So we're doing 180 minus 135 degrees. So we're not doing 135 minus 180, we're doing 180 minus 135 because our reference angle, or the horizontal axis, or our x-axis is over here. So once I do that, I get 45 degrees. So that means this theta is 45 degrees. Now this is a 45-45 triangle. If you remember about 45-45 triangle, it's an isosceles triangle where the shorter legs, or the hypotenuse, is always going to be square root 2 times your other legs. So that means we got to divide 1 by square root 2. 1 divided by square root 2, but you have to rationalize it. So we're going to multiply this by square root 2 over square root 2, which is going to give me square root 2 over 2. So that means this is square root 2 over 2, square root 2 over 2. That's some decimal number like 1 point something, I don't know exactly. Or not 1 point something, point something, I'm sorry. That means the location of this, the x value is, now, we went left square root 2 over 2. This is left direction. So this has to be negative square root 2 over 2, and we went up square root 2 over 2. That's our location. Alright, so we're able to calculate these values. Now I do expect you guys to know how to calculate the other values for the lesson test, but the last thing that we need to talk about is calculating exact trigonometric ratios. So we're going to be asked to solve things like sine pi over 6, or we might be asked to solve for tangent. Let's do, what was the other degree angle measurement I used? 7 pi over 6, and then we might have something like cosecant 3 pi over 4. Now, of course, if you try to plug these in your calculator, you're going to get decimal values. Of course, you also have to check if they're in the right mode. Make sure they're in radians if it's in radians. If you convert it to degrees, convert it to degrees. I personally always turn it to degrees. So I turn this to sine 30 degrees. I say this is tangent of 210 degrees. And then I'd say this is cosecant of 135 degrees. Now, once you have your angle measurements, with these trigonometric ratios, to get the exact value, you still have to calculate the reference angle. So this stays as sine 30 degrees. Now draw your triangle out. This should be tangent of, I believe it was 30 degrees as well. And then this is cosecant of, what is it? Cosecant of 135 degrees. Oops, 135. 45 degrees. Now I use the implication arrows on these ones because they're not exactly 30 degrees. 210 is different from 30 degrees. It's just that we're going to be using 30 degrees and 45 degrees to do calculations. Now, remember, sine is always going to be opposite over hypotenuse. In my triangle over here, opposite over hypotenuse, 1/2 divided by 1. That's going to be exactly 1/2. Any number divided by 1 is itself. So, the sine of 30 degrees is going to be 1/2. So we're able to calculate sine 30 degrees exactly. Now, a good tip is that because our radius is 1, we can think of the sine values equals y values. The cosine values, that's going to be adjacent over hypotenuse, but the hypotenuse is also 1. We can think of that as the x values on our unit circle, at least. These are very good ways to think about things. Now, tangent. We're going to be using tangent of 30 degrees first. Tangent of 30 degrees, remember, it's opposite over adjacent. So opposite over adjacent is going to be, if I go over here, opposite over adjacent. This is my angle measurement. Opposite is 1/2 over square root 3 over 2. If I multiply this out, this is the same thing. I say 1/2 times or divided by square root 3 over 2, which is equal to 1/2 times 2 over square root 3, which the 2's cancel out. We get 1 over square root 3. Okay? Oops. 2's cancel out. Yep. So tangent of 30 degrees is going to be 1 over square root 3. So tangent of 210 degrees, it is not 1 over square root 3. It is not. We also have to check the signs at times. So remember, tangent is opposite over adjacent, but you're in this quadrant over here. Now, if you look at this quadrant, tangent, you can think of it as sine over cosine. All right? If we choose these as negative values, this is negative over negative. We divide it by a negative over a negative, which actually gives me a positive. So, in this case, it does turn into 1 over square root 3. But it could be negative 1 over square root 3. You have to check your ratios. It could be negative, it could be positive, and you'll see it happen on the cosecant one. So cosecant, 45 degrees. Well, cosecant of 45 degrees, we calculate that over here. Cosecant is just 1 over, we reciprocate it, so it's 1 over cosine, 1 over sine of 45 degrees. 1 over sine of 45 degrees, well, over here, sine is your y value, right? The y value here is square root 2 over 2. So 1 over square root 2 over 2, which is equal to 2 over square root 2. But then you have to rationalize it, so you have to multiply this by square root 2 over 2 equals 2 root 2 over 2. So we just get square root 2. Okay? Now, that's cosecant. Cosecant of 45 degrees. Now, it's important that we check 135 degrees. So 135 degrees, remember, you're in the second quadrant over here. The second quadrant. Cosecant is just sine. So sine is your y values. It's the reciprocal of sine, but sine is your y values. Now my y values here are positive, which means cosecant has to be positive. So we're good to go. Remember, if it was in the third quadrant or fourth quadrant right here, if it was in this area, your sine value would be negative because your y value is negative. That means your final result has to be negative. So your reference angle, right here, you can always make this transition, but the only thing that does not is not guaranteed when you make these transition is that you are not able to determine if it's supposed to be positive or negative. It's positive or negative depending on what quadrant it is in, depending on what quadrant your original angle is located in. So that's how you calculate these trigonometric ratios exactly. I will catch you guys later for next time. Take care.